This section is about relative velocity and vectors. So, you need to rescue your dog from a raft before it goes over a waterfall. Can you do it? Maybe. And if so, what's the best strategy? How do we work it out? First, can you do it? The answer depends on many things. How fast is the river flowing? How far away is the waterfall from your dog? How far away are you from your dog? How wide is the river? How fast can you swim? How fast can you run? How fast can you swim with a dog under your arm? This sounds like a logistical nightmare. Let's make a start. Let's narrow down the scope of this problem, simplify things and put in some numbers. Let's suppose that, to begin with, you're 48 metres away from your dog. Let's also suppose that the river is flowing at 6 metres per second and that you can run at 8 metres per second. You run along the bank. When will you draw level with your dog? You need to have run 48 metres more than your dog's been carried by the river to draw level with him. This happens after 24 seconds. You've run 192 metres and your dog has been carried 144 metres. So long as the waterfall was more than 144 metres away from your dog and the river was narrow, you can rescue your dog. Another way to calculate this is by vector addition and using relative velocities. Let's look at this from your dog's point of view. We do this by taking his velocity of 6 metres per second off all of our vectors. From his point of view, he has 0 velocity. From his point of view, you have a velocity of 8 minus 6 equals 2 metres per second, and initially you are 48 metres away from him. The question now becomes, how long will it take you to reach him? You need to travel 48 metres from his point of view. Your velocity is 2 metres per second, so it will take you 48 divided by 2 equals 24 seconds again. Let's make the problem harder. Now suppose that the river is 40 metres wide, your dog's in the middle of it, and you can swim at 1 metre per second. You're going to have to swim out to save him. How much running are you going to do? How much swimming are you going to do? Let's consider 3 options. 1. Run till you are level with him, then jump in and swim to him. 2. Jump straight in and swim directly towards him. 3. Run part way, 33 metres, and then jump in and swim towards him. Which of these 3 options will take the shortest amount of time? Option 1. From your dog's point of view, you run 48 metres at 2 metres per second, and then when you are level with him, you swim 20 metres towards him. This takes a total of 44 seconds. Option 2, you jump straight in and swim towards him, covering a distance of 52 metres at 1 metre per second takes 52 seconds, a shorter distance but slower than option 1. Option 3, from your dog's point of view, you run for 33 metres at 2 metres per second and then swim 25 metres at 1 metre per second. This takes a total of 41.5 seconds, faster than options 1 and 2. After 41.5 seconds, your dog has been carried 249 metres downstream, a shorter distance than if you chose options 1 or 2, giving you more time to rescue him before the raft goes over the waterfall. So what do we conclude? Changing your point of view, that is using vector addition, can make calculations much easier. The shortest path isn't necessarily the quickest path.